Community members in Ikpiarjuk, or Arctic Bay in Nunavut, travel across landfast ice in Admiralty Inlet to the northern flow edge to carry out traditional practices of hunting and fishing. Over the last few decades, there have been several incidents where people have become stranded on ice floes that have broken free from the landfast ice, drifting into Lancaster Sound to the north. One such incident in 2013 is shown in panel E of Figure 3, where both hunters and tourists were trapped, initiating a search and rescue response. The ability to anticipate these events is crucial for improving safety of sea ice users in the springtime when these breakoff events occur. A climatology of breakoff events between 2000 and 2020 was produced by analyzing archived MODIS and RadarSat imagery. The climatology shows that there have been significant changes in the occurrences of breakoff events over the last 2 decades. Most startlingly, these events now occur over a month earlier than they did in the early 2000s, as shown by the orange line in Figure 2. And, on average, 10 events now occur per year, compared to just 5 per year 20 years ago. This climatology was used to produce a binary breakoff event variable, which was compared to environmental variables from ECMWF's ERA5 reanalysis dataset using the point-by-zero correlation test to identify relationships that trigger or precondition the ice ahead of these breakoff events. Several key relationships were identified. In the week leading up to a breakoff event, strong winds may shift the ice, positioning it more favorably for breakoff. More than a week ahead of an event, rain can contribute to preconditioning the ice by enhancing melt, thereby increasing the chance of breakoff. Conversely, snowfall more than 2.5 weeks ahead of a breakoff event can insulate the ice, inhibiting melt and decreasing the chance of breakoff. These relationships were used to produce predictive logistic regression models. However, the skill of the predictions were poor. The primary challenge of the current modeling attempt is the quality of both the environmental and climatology datasets. In situ environmental observations would be a significant improvement over the reanalysis data used in this study and could be collected through the deployment of instruments near the flow edge like weather stations, ice sensors, and ocean buoys. Additionally, the greater frequency of images produced by the recently launched RadarSat Constellation mission would help to improve the temporal resolution of observed breakoff events in the coming years.